Hello, this is 3-3, solving linear systems. Remember, linear means that we've got variables to the first power. Systems means that we have two or more lines represented. So now you've learned how to solve these with graphing, and you've learned how to solve these with substitution. When I give you these two, you could solve it by substitution, which means since this is a variable that has a 1, you would get it by itself, and it might look something like this. You subtract 2y from each side, get the x alone, then you take what x is equal to, and you plug it in to the other equation in place of x, and then you distribute and go through and do all this work, and you get y equals 2, and you plug that 2 in for y, and you find that x equals 4. But today, I'm going to show you another way that you could solve the system that's a little bit faster. I think I'm inclined not to teach this in class. If you watch the video, you'll have it. So here's the equation again after I wiped it out with my hand. It was 4x minus 2y equals 12, and x plus 2y equals 8. When I look at this, I notice that my y's are exactly opposite. This is a negative 2y, this is a positive 2y. Remember when we had the tiles on the board and we had 2 red y's and 2 blue or yellow y's, and that made 0 pairs? We can look at this and see that. We could actually get out the tiles and do this, so all I want to do is add them together. These would wipe out and make 0 pair. This is a 1x, so we have 5x equals 20, and now we're down to our final step here. We circle the x, divide by 5, and we find that x equals 4. That is a little bit quicker, and that's why I use it, than doing substitution. There's a lot less work involved, just because these line up nicely. Now once I get the 4, don't forget, I'm thinking of a solution to a system, so it should be a point, especially since I found the x value. All I need to do is take this 4 and plug it into one of these equations for the x. Either one will work, because you're going to get the same y value. So I'm going to go with the easier one here. 4, plug that in for the x. 4 plus 2y equals 8. I subtract 4 from each side. I find that 2y equals 4. Divide by 2, and I find that y equals 2. Now I should write this as a point for 2, because that means that these two lines cross or intersect at the point 4, 2. Okay. Here's another one. Now this time, if you look at this, you might say, wow, we want to do it the fast way again. However, if we add these are not opposites. Remember what created that nice setup the last time is that the y values were exact opposites, a negative 2 and a positive 2. If I add these, 6 and a negative 1 would make 5y, or 2x and 2x would make 4x. But if you look at this and you see, well, these are exactly the same, you say all I need to do is multiply by a negative 1 on all these terms. That would keep this equal, and then I could add like I did before. You are exactly right. So this time, write this in your notes. Some people say they're subtracting. I say just go through and change all the signs on one equation so that you can add the opposites. So minus, plus, plus, and now just add like you did before. 2x minus 2x would wipe out, that's 0, because these are all red, those are all regular color, and so they wipe out as a 0 pair. 6y plus y would be 7y. 6 and 8 is 14. Divide by 7. And we get y equals 2. Now we need to plug back into one of these equations. I say normally plug into the one that you haven't changed, just so you don't have any added possibility of error. So we plug 2 in for the y, not the x. So we have 2x plus 6, instead of the y we put 2, equals 6. Go ahead and get rid of your parentheses. 2x plus 12 equals 6. Circle our creepy dude. Get rid of the first thing. It's got a plus 12, so we subtract 12. That wipes out. 2x equals negative 6. It's being multiplied, so we divide. X equals negative 3. So our point is 3, 2. Oh, I'm sorry, negative 3, 2. Okay? It might not be a bad idea to go ahead and graph those and just check and see if it really crosses at negative 3, 2. Just as another possible check. Oh, here we go. 2 ways to check, plug and chug or graph. So, let's go back to this last equation. We had 2x plus 6y equals 6. We say that the solution is negative 3, 2. So if we plug in negative 3 for the x, that would be 2 times negative 3 is negative 6, plus 6 times 2 is 12. Negative 6 and a positive 12 does equal 6. So that works for that graph. Now looking at the other graph was 2x minus y equals negative 8. 2 times negative 3 is negative 6 minus 2, because we plug in the positive 2 and there's a minus there, equals negative 8. These are all red, these are all red, that would just make more red. So by plug and chug, we've checked it. Now let's check it by graphing. Just erase down here and we'll figure out our graphs. If x was 0, y would be 1, because that wipes out. 6 times 1 is 6. If y is 0, then x is 3. Because 3 times x would make 6. Now over here, if x is 0, y would be 8, because the negative makes it negative 8. If y is 0, then x needs to be negative 4 to make that be equal to negative 8. Okay? So now we go to the graph, and I just put in those points. So 0, 1, 3, 0, okay. On the other one, it's 0, 8, and it's negative, it's 0, I mean negative 4, 0, negative 4, 0, and I said my point is negative 3, 2. 1, 2, 3, 2. I'm off just slightly. Remember, graphing is an estimate. Okay? So the last thing I wanted to show you. When you come to a system, look at your variables. If your x's, let's say there are 3x and negative 3x, in the two different equations, then you know that they're opposites. That's a signal to you just to add those equations, because they'll wipe out. Now, if you come to them and they happen to be the same, like that, all you need to do is take a negative, change all the signs in one of the equations. So change all the signs in the bottom one maybe, and then you just add, and you're adding the opposites, and you'll have this situation. So that just kind of helps you. Look at both variables, the x and the y. If either of them have the same variable, the same coefficient, just multiply one of those coefficients, that whole equation, by a negative, then you'll have opposites. Once you have them opposite, then you can add them and they'll wipe each other out. Okay, see you in class tomorrow.